Hi, everyone. It's really great to be here in Malaga at Jay on the Beach. This is my first in-person conference in over 2 years, and I am just overwhelmed with excitement to actually be able to talk to you and see your faces looking back at me. It's really great. Today, I'm going to be talking about shifting left the wrong way. So it's a bit of a retrospective on the things that we've learned in the DevOps community over the past decade. DevOps feels like it's old news now, doesn't it? It's been a thing for over a decade, and it's a term that's been used and abused to the point where it has almost lost all of its meaning. The bad news is that the problems that DevOps set out to solve are still there for many of us today. And I've been doing this DevOps thing for a while now, and I've learned a few lessons, and so that's what I'm going to hope to share with you today. Some of the patterns that make shifting left successful, some of the things that make shifting left really hard and actually can make things worse. In 2010, DevOps set off to solve this problem, the wall of confusion. On the left, dev teams focus on features. On the right, ops teams are focused on stability and reliability. So it's changing all the things versus changing none of the things. Devs would release software, they'd throw it over the wall to ops, and ops would have to babysit that in production. They didn't get a say in what they took. They had to make it work. They had to make it work for their users. It was a world of poor handoffs, terrible feedback, and a miserable experience for everyone involved. I can vouch for that, because in 2010, I was a release manager. I was literally sat on top of that wall of confusion, trying to get these two teams to talk to each other and to collaborate. And I can honestly say that it was incredibly, incredibly hard. And those experiences of how painful it was to ship software, even though we were only trying to do it once every quarter at that time, is why I took an interest in DevOps in the beginning. I thought, this doesn't work. I shouldn't be pushing small changes into production and having them blow up in my face every other day. I shouldn't be having to coax operations teams into supporting our business with the features and the development that our users were asking for. And so I got involved in DevOps in the early days, and I've been part of the community ever since. So what I'm going to talk about today is some of the things that we've learned along the way. The DevOps problems of 2010 were, of course, a point in time. The technologies we were using were very different. Since then, we have embraced new tools, new platforms, new engineering practices. We've built amazing communities, open source foundations. We've learned from each other, and we've learned from visionary leaders. Before DevOps was called DevOps, the problem that it was trying to solve was very much the same, and the problem remains the same today. How do we deliver software rapidly, safely, and securely into the hands of our users whose expectations of us are increasing all the time? You'll be relieved to hear that this isn't a talk about Kubernetes. The processes and practices that I'm advocating for today should be transferable to any team trying to deliver software. But in my day job, I work with really large organizations. I work with banks, I work with governments, retailers, transport. And some of the simple ideas that I'll share today, they can actually take years to implement in those organizations. But it doesn't matter whether you're big, small, whether you're more dev or more ops. I hope there's something that you can take away from this talk today. But when I talk about building platforms, I'm often talking about Kubernetes-based application platforms, because that's what me and my team do day in, day out. But if you're using cloud-native services, if you're using PaaS services, SaaS, you probably have some of these challenges too. They might just look and feel a little bit different. It was 2006, which is quite a while ago, that this narrative was shared by the CTO of Amazon. You build it, you run it. Sounds like a good idea. As development teams, you have the domain knowledge about how your software works. You know if it's functioning correctly, doing what it needs to do. You know if it's performing well, and most importantly, you know how to fix it when it breaks. Today, dev teams are so often more than just application developers. They include many different roles, creating cross-functional teams who can deliver value autonomously. And if you're part of one of those balanced, autonomous delivery teams, and if that's just awesome. Like, you should keep doing that for as long as you can. But if, however, you're part of a larger organization, if you're consuming shared services in a centralized manner, if you're building some of those shared services, maybe you're building back-end services that support your application front-end, then this talk is definitely for you. I'm talking about how we deliver value to our users when we're a team of teams, when we're not able in small groups of people to deliver that value autonomously, when we have, by the nature of our problem space, a larger area to solve for. So how do you apply you build it, you run it when there's more than one team building things and running things? How do you still keep all of that DevOps goodness without rebuilding that wall of confusion, without creating more silos in your organization? Production is where your users are. It's where we all ultimately deliver value for our business. Production is the happiest place on earth. But so many organizations I work with are afraid of production. They're afraid of change. They're afraid of breaking prod. The goal of all of this DevOps goodness is to unblock that path to production, to delight our users by streamlining the process and removing the handoffs that get in the way of us delivering and delighting for our users. But even though we all know that this is our mission, we still struggle as a community. Getting software production is still really hard. And I wanted to share a couple of these stats with you because these were really eye-opening for me. 52% of net new apps never make it to production. They never get into the hands of their users. They're abandoned before they even meet the real world. 54% of software updates and upgrades never make it to production. Oh, actually, am I saying this the wrong way around? I am, aren't I? So 52% make it to production, that means 48% don't. It's still a pretty frightening statistic, isn't it? But yes, you understand what I'm saying. So, and also 51% don't make it to production in the planned timeframe. That means 49% don't. They slip. And I think this is a common problem, and I'm sure there's a lot of stories you could tell me about these problems that you've encountered, how many times you've been working hard on a new development only to find that it didn't really do what you needed to do, or budget ran out, or priorities changed. You know, this is a really common problem that we see everywhere. Back in the old days of DevOps, there was this hilarious no-ops movement. Some folks shifted left to the extreme. They went so far as to say that the problem with shipping software safely, securely, and quickly into the hands of the users was the ops team themselves. And that says a lot about the challenges that people were facing in their organizations, where they felt like it was impossible to succeed with the ops team still there, the ops team still in place. And it's a clear case of where misaligned incentives and misaligned objectives really hurt the people involved in those organizations. No collaboration could be foreseen, and it was better to champion the absence of ops in its entirety than to figure out a way to work with them. As silly as that no-ops idea sounds to anyone who's involved in ops-type work today, we continue to see some of this play out. Shifting left is obviously a great idea. We want to be getting fast feedback. We want to be making decisions at the point within the team closest to the development, closest to the delivery. But have we thrown too many of these concerns back over that wall of confusion? Have we thrown too much complexity at our development teams in the pursuit of velocity, in the pursuit of that breaking down those silos? We know that teams who have autonomy and ownership are more productive, happier, and healthier, but is there a tipping point? How much responsibility is it realistic for a dev team to take on? Is the domain knowledge needed to do it well simply too much for one team? And shouldn't building apps for their users be the priority anyway? Shouldn't be delivering value for the business be their priority? And I know that I said this talk isn't about Kubernetes, but Kubernetes is certainly highlighted this problem in our space. It really grazed the boundary between application and infrastructure, and I think it's a fantastic platform for delivering infrastructure in a really application-centric way. But we are pushing a lot of that complexity into our development teams. I heard this very devastating news the other day, which may not come as a surprise to everyone here, that apparently developers don't really like working with YAML. And it's not surprising. And with Kubernetes specifically, it's an enormous surface area to work with. There's an awful lot that you can do with it. And it's an awful lot of complexity to push into the realm of development. And when I look at the increasing demand for velocity and agility alongside the increasing complexity that each developer needs to wrestle with every day, I'm not surprised when I see stats like this. A recent report by Haystack Analytics found that 83% of developers report suffering from burnout, and I don't think that's okay. We need to do better as a tech community to address these problems. How many people in this room hold the pager for their organization? I can just about see you. It's quite bright up here. Give me a wave if you're holding the pager right now. There's a few hands. So back in 2014, I started my own DevOps consultancy, and we were focused very focused on infrastructure as code. We were going around automating Windows platforms and Azure platforms with Chef. That was the best tool for the job back in 2014. And when we were going into these organizations, we were trying to solve some of these really hard technical problems. The thing that really impacted me from that experience was it was the people problems, the human problems, that were far more challenging to solve. And that's when I got involved in the human ops movement. It was a sort of subset of the DevOps community in London where we talked about the people-related issues, the cultural shift that you needed to make, the practices that were technology agnostic that would set you up for success or for failure. One of the tenets of human ops was that the well-being of your team will impact the health of your system. And I don't think it takes a huge kind of leap to see how that might be true. We only need to look at the health impacts of sleep deprivation, things like high blood pressure, cardiovascular disease, stress, not to mention the impact on your personal life and relationships, to see that these are problems that, as a community, we need to be focused on and that we need to have conversations about more often. So going back to you build it, you run it, that still feels like the right approach. But how can we do this without burning out our development teams? How do we achieve this balance and sustainability when we have so many problems to solve? I've seen several times in my career what happens when too many tasks are shifted left. Too many tasks are shifted into the development team. The harder things are to do that don't directly impact the value to the customers, the less likely they are to be prioritized. I've definitely seen that to be true in more than one organization. We shift left, and then those things that we know to be important end up at the bottom of the backlog or basically never progressed, because there are more important things to be done. Our users are asking us for more every day. So to shift left successfully, we need a different approach. No ops isn't the answer, in my opinion, nor is the old dev and ops siloed way of doing things throwing code over the wall. Good fences make good neighbors. So I'm going to talk about the practical changes you can make to solve some of these age-old problems. And this is a really simple model, very, very simple, that describes how I think about building platforms and building platform teams. There are many, many ways you can organize your teams, but this is something that I've seen to be successful in the organizations that I work with. And of course, you would need to adapt it for your context. The application team delivers apps and services for their end users. They build it and they support it. The platform team provide a platform service for the application teams. They unblock their path to production. They provide the tools and technologies that they need to be able to run their applications successfully. They build that platform and they support that platform. And of course, somewhere there's an infrastructure team. There's an infrastructure team, even if you're using the public cloud, it's just not your infrastructure team. But there is an infrastructure team that's providing an infrastructure service that the platform team consumes. And guess what? They build it and they support it. And all of these teams need to adopt a product mindset because all of these teams have users and all of these users have needs. Every one of these teams has the same mission when you boil it down. They want to build an amazing product and a valuable service for their users. It's just that their users are different. The infrastructure is being consumed by platform teams and maybe directly by application teams. Those platform teams, their service is being consumed by developers. They need to care about those users. They need to, otherwise, those users are going to go elsewhere, and we may not be happy about where they go. So we need to take a really user-centric approach when we organize our teams like this. And that's one of the ways that I've seen large organizations being successful whilst also maintaining developer productivity without shifting too much of that complexity into that application domain. And of course, our users never stop changing. Our users outside of our organization never stop changing, but our users inside our own organization, their needs change as well. New tools and technologies are adopted. We need to continuously evolve the platforms that we build for them. And with the constant evolution of our end users, we need to evolve every part of our organization. We need to build, measure, and learn to make sure we stay relevant. How many platform projects have you been a part of that you've seen fail because they don't meet the needs of their users? This is about product versus project. Products evolve over time as their users need. You deliver value incrementally and continuously. Projects set out with a goal in mind and they end. So taking a product mindset to the building of platforms and infrastructure is a really critical enabler to stay relevant and to make sure that your team is set up for success and that you're evolving with the needs of your business and the needs of your users. Since 2018, I've been part of a platform engineering team. This team was originally at Pivotal, and then in 2020, we were acquired by VMware. We're now called VMware Tanzu. I meet so many teams and organizations as part of my job that are wrestling with the same problems, and I try to help them. The State of DevOps report last year picked up 2 key patterns for success, and I've seen these patterns work in the real world, and these are product mindset and self-service, especially when building internal developer platforms. So I'm going to talk about how these changes in approach can improve your velocity, reliability, and security. Product mindset and self-service. It's easy to default to the same old ways of working when you're building platforms, even when you know you need to do something different, even though when you're trying to do something new. We take a project approach, which means that we disband the team or we scale down the team once a minimum viable platform is in place. We build in a vacuum, never asking our users what they need from us, resulting in over-engineering or launching a platform product that's not fit for purpose, something that doesn't add value to the business or potentially makes things harder. We do big design up front. We try to make every single technical decision that could ever need to be made and serve every single potential user of these platforms. And we get completely bogged down with that. We get analysis paralysis. Instead, we should be iterating through that build, measure, learn cycle, delivering value incrementally and as early as possible. So we get that feedback and we build something that's relevant to our users so that we improve that developer experience of using our platforms. And of course, we often route requests through ticketing systems, and humans, instead of surfacing those capabilities, those platform capabilities, through an API that can be adopted in a self-service model. That's really the key to scaling. Tickets and humans don't scale. We need to make sure that these capabilities can be surfaced through an API in a secure and reliable way so that developers can self-serve those things, maybe with a little bit of help and enablement. When we adopt a product mindset to this problem and a user-centric approach to building platforms, we can have a huge impact on developer productivity. We abstract away all of that complexity I was talking about before, all of that complexity that we continue to shift left into the application domain. And we can focus on building an experience for our users, our application developers. We can use developer experience practices to further make the platform a compelling proposition. If you haven't read this book, please go away and read this book. It's incredibly good and insightful. And in team topologies, the definition of platform is one that I particularly like. A platform is a curated experience for engineers who are the consumers of that platform. And platform doesn't just apply to things like Kubernetes or things like your cloud platform. Platform can apply to your shared services. It could apply to the login and identity service that your consumers use. You might have multiple applications calling into that identity service to authenticate. You can take a platform approach to those shared services within your application domain as well. So I've talked about building, measuring, and learning. I've talked a lot about building and shipping, seeking feedback, iterating, delivering continuously instead of in big, scary batches. So next I'm going to talk about reliability and how some of the core SRE practices can also help us overcome that wall of confusion. Velocity is important, but I always say this, reliability is fundamental. It doesn't matter how many shiny new features you are shipping if your service is unavailable to your users or it's too slow for them to use. Reliability is at the core of everything that we do. With that in mind, I want to talk a little bit about some of the core SRE practices around service level indicators, service level objectives, and error budgets, and how these concepts work across team boundaries when you're delivering a service that depends on other services. I'll start with a bit of a high-level definition of these terms, just in case there's anyone in the room who hasn't come across these terms before. So a service level indicator is a metric. Simply put, it's a metric that is a proxy for your users' happiness. It should be measurable, it should be unambiguous, and it should correlate very highly with whether or not your users are happy with their service. Your service level objective is the level that you want to achieve. So it's often expressed as a percentage. So you might hear terms like 3 nines, 99.9% as an SLO. And then, of course, your error budget is the inverse of your SLO. So when you set your service level objective, the service level you want to achieve for that service level indicator, you're going to have a little bit left over, and your error budget is how you measure that. And I think error budgets are an incredibly useful tool to talk about reliability, to measure reliability, and to create really much more healthy conversations about supporting production services. Because 100% isn't your target. You cannot build a service that is 100% available all of the time. You can get very, 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 very close, but of course, the more reliability you want out of your service, the more resilience and redundancy and complexity that you need to build into it. And there is a cost associated with that. There is always a trade-off. So 100% isn't your target. So you need to decide what is. What level of service do your users actually need? And how are you going to measure it? What are those key indicators of whether or not your service is doing the job that it was built for? I like to talk about error budgets in terms of time. Time isn't the only way to measure your error budget, but it's a concept that everybody understands. So it's a really good way to get started with an error budget. So just to give you an idea, in terms of error budgets expressed in time, if you want to achieve an SLO of 99%, then your error budget over every month is 403 minutes. And that feels pretty achievable, doesn't it? For most people. But as you can see, the more nines you add, the more challenging your error budget becomes. And of course, when you get down to 4 nines or 5 nines, we're looking at error budgets of less than 5 minutes. We're talking about 4 minutes. We're talking about seconds at the bottom end of things. And of course, when we reason about how we achieve such a very high SLO, you can see from those that isn't even enough time for a pager to go off and for the engineer on call to potentially wake up, open their laptop and log in. You're going to have to invest in an awful lot of automated failover and automated recovery in every element of your system, all the way down, if you want to achieve 4 nines or 5 nines. So as I mentioned earlier, these tools and practices allow us to balance change and reliability. We know we need to change, but we also need to make sure that the reliability of the service that we provide isn't impacted by that continuous change. But how does it work in practice? What do we need to think about when we're setting our service level objectives? So I'm going to talk you through some of the economics of setting your SLOs. So on the bottom here, you'll see that we've got our number of nines. So on the right-hand side, you've got 5 nines, so the highest levels of reliability that you might be aiming for. And of course, as I said, there's a cost associated with it. There's an exponentially increasing cost the more reliability you want out of your system. And it's because of that extra resiliency, redundancy, and automated recovery that you're going to have to build into your system. We've got another line here as well, which is the likelihood that anybody's going to notice a very, very tiny outage of your service. And of course, the higher the availability of your service, the less likely it is that anyone's going to notice any failures if they're very, very small and infrequent. And then there's another line, of course. Does anyone care? So if your service is down for 5 minutes, are your users going to come back in 5 minutes? I used to work on an e-commerce website, and this is back in the days when I was a release manager. And what was really interesting is when we did blow up production, as we did quite frequently, our users came back. They were like, oh, I can't do my online shopping right now. I'll do it in half an hour. We didn't really lose an awful lot of orders through that, but I can imagine that there are some services where your users are less forgiving. And you need to take that into account. You need to really understand the needs of your users so that you can set your objectives in the right place. And when we talk about the level of sort of operational maturity and the investment in reliability that you want to make, reliability engineering, is going to be different depending on what your users need. So if I flick through this a bit, we start at the very low end. If you've got a very large error budget and you know that your users aren't detrimentally impacted by an outage of a certain duration, then you can rely on manual processes. You might be able to rely on human intervention. You might be able to rely on manual inspection even to provide the level of service that you need. Maybe you're working in an organization where you're building internal applications that are only used during business hours. Well, you're going to have quite a large error budget there. So it's not a one-size-fits-all solution. You need to invest in the right level of reliability for your team. And of course, the higher you get, the more challenging it gets. When we embrace shifting left and the you build it, you run it model for application delivery, we need to have a discussion about who owns that error budget, especially if we're relying on shared services to deliver the availability we need to our users. So let's say your users want 3 nines of availability. You've had that conversation. You think 3 nines, 99.9% availability is what your users will accept from your service. Who gets to use that 40 minutes of error budget? If the platform team use that whole error budget, it doesn't leave anything left for the application team or the infrastructure team. And that's not fair. So we have to take a really user-centric approach from the outside in. What level of service do our users need? And how are we going to negotiate the relevant SLOs for each of the services that ensure that we have a user experience that is reliable enough for our customers? And the bad news is that internal platforms, especially ones that serve multiple tenants, must provide a higher level of reliability than the application. So it gets harder and harder, and the needs get greater as you go down the stack, and it doesn't come for free. So as an example, if your application needs 3 nines of availability, you've got an error budget of 40.3 minutes. And what you might do to allow the application team to achieve that, to make sure that they can achieve that, is you might set a higher SLO at the platform level. You might go 99.95. That platform team then has an error budget of 20.2 minutes. And then as you go down the stack, the platform team is consuming infrastructure, and you really want that infrastructure to be much more reliable. You don't want your infrastructure team to be consuming a lot of that error budget. So you might decide that your infrastructure team need to provide an SLO of 4 nines. But the important thing is that you have a conversation about this. What are my expectations of you, and what can you expect from me in terms of reliability? And if you can't provide the level of reliability that your users are expecting, then that's a conversation that you can have about investment. We need to build more resiliency into our system. We need to build more automated recovery into our system because our users are demanding this of us. And not shipping changes and being static and staying still, that's not an option in our business today. Reliability is everyone's goal. And again, I think it's one of those things that can very often get delegated to a platform team. But reliability is a team sport, and everybody needs to be involved in reliability. You can improve reliability through the architecture of your application, through your user experience even. You can do graceful degradation in the front end of certain services. There's a lot of things that you can do to invest in reliability that are outside of the world of platform. But quite often I see the reliability being delegated to platform teams, which isn't right. Reliability is everyone's job. Reliability is a team sport in any organization. And this user-centric approach, when we apply it to day 2 concerns like reliability, still works really well. A couple of years ago, I was helping a customer get started with these SRE practices. I was introducing them to the concepts of SLIs, SLOs, error budgets, and we spent a week together with their platform team and their development teams who were early adopters. We were looking at how are we going to set this team up for success? And ultimately, the platform team needed to help that application team achieve their SLOs. We were a key dependency for those application teams and their users to perform in production, to be available in production. So we set service level objectives around availability. That was very intuitive. But what we also did is we set ourselves service level objectives around developer experience, because developer experience of the platform in pre-production also matters. Availability of the platform in pre-production also matters. The cost to the business of an outage might not be as high as a cost of a production outage, but there is a cost. And it is worth a conversation of what level of reliability and availability we would expect in non-prod. And I think, taking that shared responsibility and taking an interest in the service that you provide, not just in production, but in pre-production, is a great way to break down those silos. It's a great way to build trust and collaboration, and also, provide transparency and visibility. This is the service level that I'm going to offer you in pre-production to help you do your job better. So I've talked about developer experiences and platforms that enable velocity on the path to production. I've talked about how some of our SRE practices can also be used to provide that developer experience and improve your reliability, reliability being everyone's goal, a shared goal. And so now I'm going to talk about another concern that affects all of us, which of course is security, and how you build a culture around security when you're building across multiple teams. When I was working as a release manager, and I tell stories about this time of my life quite a lot. It was obviously one of those very painful times in my life, but because I've got so many horror stories from it. But when I was this release manager, I sat next to one of our security architects. And I remember this incredibly awkward conversation with him one day, and he got quite angry with me. And he said, "Why didn't you tell me there was a new release?" And I kind of looked confused. I was like, there's always a new release, Simon. There's always going to be a next release. I am always planning something. And It's really, it's really telling of the difference in security practices that we were able to implement, say, 10, 15 years ago, where point-in-time security assessments were the norm. I am going to plan this release, and on that release plan, there will be a security assessment, and we will tick all of those boxes, and only then will we ship to production. And we might do some penetration testing in production as well. But those point-in-time security assessments, they don't work anymore. They don't work if we're continuously delivering change. They don't work with the complexity of the technical landscape that we have in front of us today. Those ways of working are over. Continuous delivery requires continuous security, and that's a change in mindset for a lot of the security architects and specialists that are out there, especially the ones that I work with in these very large global organizations. Unlike investments in reliability and scalability, where the benefits can be really felt by the engineers on call, the benefits of really robust security practices are often really a lot more invisible, a lot less tangible. The absence of security incidents in your organization is not evidence of good security practices. One of my colleagues used to compare patching with flossing. We know we should do it because it's good for our oral health. We're going to keep our teeth for longer if we floss, but so many of us, myself included, we choose not to floss because it's a chore and it's boring and there's no immediate payoff for it. There's no reward. You do it to prevent bad things happening in the future, and a lot of security improvement work, it falls under this category of chores, and it can often get deprioritized. And it's human nature to avoid chores, especially if there's more interesting, rewarding or urgent work on your plate at that time. We don't need to talk about Log4j, do we? No? Okay. We've had some fun with CVEs recently as a community, and I think a lot of teams, a lot of people that I talked to were caught a little bit unprepared. They didn't know what code was running where. They didn't have the traceability. They didn't have the secure software supply chain. They didn't have automated processes to remediate critical CVEs when they're discovered. And it's brought security really to the forefront of people's thinking at the moment, but it won't be long. Unless we invest in it, it won't be long before it slips down the backlog again. We all know how important security is, but it is so often neglected. And so I'm going to talk about some ways that we can look at security in a different way and change our culture around security. I'm going to talk very briefly about psychological safety, but I'm also going to talk about how we take a user-centric approach to security, how we improve developer experience, there's that word again, around security. Because security processes can create friction. Especially if you have a security team with a very traditional mindset who wants to still do those point-in-time security assessments. It can slow down development as well as making operations tasks more difficult. And that breeds a culture where backdoors, workarounds, and shortcuts are common. If it feels impossible to do everything the security team are asking you to do and achieve your objectives and do your day job, then we quite often find another way. And that's not okay. We need to be working collaboratively to improve security, not opposing each other in our organizations. We need to be able to talk openly about issues with the processes and practices and issues with the security posture of our existing platforms and applications. So let's start with psychological safety. Can I get a little wave from anyone who's heard this term before? Oh, not many hands. Okay, so I'll go into a little bit of background of psychological safety. So the definition of psychological safety, the one that I like, is that it's a belief that no one will be punished or humiliated for speaking up with ideas, questions, concerns, or mistakes. The highest performing teams have been shown in research to have high levels of psychological safety. And one of the really interesting research projects that Amy Edmondson has led was in a medical context. And what she did was she was looking at the error rates within a medical context, so how often mistakes were reported. She was also looking at quality of service and patient outcomes. And what she found seems counterintuitive. The teams where you had much higher error rates, much higher recorded mistakes on those teams, they actually had better patient outcomes. They were providing a much higher level of service. And that was because actually the mistakes were happening everywhere, but in those teams, they were talking about it openly. They were talking about it transparently. And they were learning from those mistakes to improve the service that they were delivering. That's, it feels counterintuitive, but actually you can see how it would happen in the real world. If you're going to be blamed for a mistake, if you are going to be punished for a mistake, if people feel unsafe to talk about things that they've done wrong, then they simply won't. They'll hide it. The blame game is very real, and it's a really destructive force in many organizations. There was also a similar study done within Google, Project Aristotle, which looked again systematically at what were the differentiating factors that led to higher team performance. And again, psychological safety came out on top. Teams with higher psychological safety performed better overall. And I talk about psychological safety in the context of SRE. I won't go into that now, but just the language of talking about an error budget can really start to break down some of that fear of errors, some of that fear of outages, that sense that every outage is a disaster and it should never happen again mentality that we see so often. So creating a culture where you can talk about security is first base. This is what you need to do if you haven't done it already. You need to be able to talk openly and honestly about security. If you have people in your organization whose sole purpose is security architects, security specialists, then task them with education. Don't have them handing down mandates that can't be implemented. Task them with collaboration and education. Measure where you are honestly and transparently, and then you can work and iterate towards improving it. And of course, if you want to get better at anything, it's really good to celebrate your successes. Okay, we've moved the needle. We might not be where we want to be at the moment, but we're getting there. And you can't do that if you don't talk about security openly, if you don't point at security vulnerabilities, if you don't point at security problems and say, hey, this is something that I think we need to invest time in fixing. So talking about security is important. Getting that topic out in the open. The next thing you need to do is to make it easy to do the right thing. If you make it easy to do the right thing, then by default, you'll be more secure. You won't have people finding workarounds. You won't have people finding backdoors. You won't have vulnerabilities that you don't know about within your system. If a security improvement negatively impacts your productivity, then at best you're going to breed resentment, and at worst you're going to inadvertently encourage teams to find their own solutions, which may be less secure. They may not have the knowledge that they need to implement it in the right way. And you might be impacting employee experience and contributing to attrition within your organization in the process. You need to really think about how you build better security practices into every element of what you're doing, but you need to do that in a way that's user-friendly. You need to think about how feasible it is to implement those things. I'd actually go so far as to argue that security initiatives that are implemented without a user-centric approach will degrade your security posture over time. You will make things worse if you don't take a user-centric approach. Teams will figure out how to work around the process, or they'll think of something that works for them that you may not necessarily approve of. And with that in mind, I'm going to advocate for the following steps to make it easier to do the right thing. And again, I'm oversimplifying here, but hopefully there are some ideas that you can take away from this and implement within your organization. Like reliability, shared ownership of security is so important. You can't delegate this to someone else. This is part of everyone's role and everyone's job, and there's a certain amount of education that we all need to be responsible for when we're talking about security of our applications and our platforms. We need to automate away the toil. I talked about a lot of security work coming into the category of chores. There's no immediate payoff. There's not a lot of motivation to do that work compared to something that your users are screaming at you for, even though we know that it's important. So automate it, make it really easy, make it really streamlined. And measure it. What is our cycle time? Like, how can we put some metrics around this that make it more tangible? What is our cycle time to patch a new CVE? How do we go from like CVE notification to having all of our infrastructure patched? Those are things that we can measure, and we can measure them frequently, and we can get better at them. And then, of course, as I've said, taking a user-centric approach and a product mindset. So if you are a security specialist within your organization, how can you engage with development teams? How can you make life better and easier for them? So often I find people putting up walls around themselves and mandating practices and processes that aren't user-centric, that don't work in the real world. And that, I believe, causes security to degrade over time and not improve. So I'm going to wrap up now by reflecting on some of the things that we've covered today. But really, over the past decade, we've learned a lot. Too much for me to share in this short talk, but these are the key things for me. DevOps and the problem that we set out to solve is still a problem today. We figured out ways to build platforms that unlock velocity for development teams. We've figured out how to create practices and processes, things like error budgets and SLOs, for taking shared ownership of reliability and not delegating it to someone else. And we're just now starting as a community to think about security in a user-centric way. We've got a lot more tools and technologies at our disposal than we did 10 years ago, where we said, shift security left, and then it was like, well, how? We have tools and technologies available to us to allow us to do that, to allow us to do continuous delivery with continuous security. But at the heart of it, really, it's about people. And, as I said, the tools and technologies will change, and they will continue to change. And the thing that I'm most interested in, and some of the hardest problems to solve, is how we work together to solve them. So I hope I've given you some ideas of how to shift some of these concerns left, but also how to deliver a better developer experience and make life better for the humans involved in this endeavor of delivering applications in this very complex technology landscape that we now operate in. Thank you, everyone, for coming along today. I hope you have something to take away from that. And I don't know how much time we have for questions, so I'm going to look over here and ask.
I think we have time for a question.
One question, awesome.
So, and then they're going to have to berate you in the break. So first of all, let's give a very big thank you to Hannah. Okay, cool. All right, so I have 3 questions here, but I'm going to pick this last one that was just, and I wish I could see who in the audience submitted it, but okay. It says, how do application teams achieve autonomy in situations where delivering features depends on first implementing part of it in services owned by the platform team?
Yeah,
it's kind of a mouthful. Sorry.
No, I've been in this situation before. I think the example I would give is when I was head of technology for the team responsible for the back-end identity service, the login service that our users authenticated with, and I was everyone's favorite dependency. Everyone in the organization was like, when's it going to be ready? I can't build my app if I can't authenticate my users. And I think one of the really important things that we did there was we were really transparent with our roadmap, and we were really explicit about who we were bringing on board as early adopters and who we weren't, and allowing people to find alternatives, because you do need to continue to deliver. And I think actually, underinvestment in some of those shared services is a common pattern, because it's not quite as sexy or as tangible as the user-facing applications. But these underlying services, these shared services, are absolutely critical to ensuring velocity within your entire organization. Otherwise, they will become a bottleneck. I don't know whether that answers the question. That was just me going like, yeah, it's hard. Yeah.
But it sounds like what you're doing is you're being very transparent as well in the organization.
Transparency is key. Yeah, absolutely. And you really want to bring your early adopters really close to your team to make sure you're delivering a viable service for them, and then you evolve and you iterate from there, bringing more people on board.
Mm-hmm. And I think that's really a good testament to building any new application or service model or whatever it is that you're doing. It's building transparency and building iterations off of that. So I certainly got a wealth of information that I will be taking to my own project management in general.
Oh, excellent.
So just another big thank you to Hannah. We'll have, you'll be able to find her in the audience later.